This here is, as you see, a fetus with profile, assuming it's a prefrontal edema of 8 millimeters. So, but is it a prefrontal edema, Bernard, or what do you think?
So if you use 3D, you have to check on the multiplanar plane to know if it's exactly the mid-sagittal plane. So
what I do here is you hit the button of not single but multiplanar. And you see here that in the B plane, here, we are oblique. So this is why the first thing you should do when you are working on 3D static mode is to readjust the planes in order to get the proper mid-sagittal view. So I will take the dot and remember that the dot is always the intersection of the 3 planes. You see this, the dot here, I will put it, choose the A plane. I will put it on the, let's say, tip of the nose, a little bit lower. And then I will move to the B plane and rotate the whole around the Z-axis. And you see how the thickness, the so-called thickness is changing, because if you take it obliquely, it's different. And then I will move in the B plane from up to down and readjust the lower image in the C plane here, again, to have a horizontal view. And then now you see this is the true profile comparison to the one we saw before. This should be done when you work on multiplanar. Theoretically, if you want to see the face, to see the eyes, and to document all these, you can go and choose tomographic imaging. So this is all, it is called the multiplanar rendering. This is the orthogonal rendering done. This is now tomographic imaging. In the tomographic imaging, you can choose here the number of slices, and you can choose the distance between the slices. So if we have 7, we'll add 1. Let's augment the distance of 2 millimeters. I will augment it, and you see here, what you see here is the distance will be changing here. And then there is no secret what are the numbers you can take, but you should know what you want to demonstrate. So I will, what I want to have on this picture is, in comparison to the midline, one orbit and the other orbit to be seen completely. So I have in the upper image here one orbit, in the lower image the other orbit, and I see in the mid-sagittal view the face. I can choose also the C plane, but going from up to down. And then you can demonstrate here the eyes and the lenses, and this view to demonstrate the planes we want to demonstrate. So you can choose the distance between the images and so on. But in general, this is a view of the face. You will document abnormality or normality, but most of us will render with the 3D.
Yes.
Show us what are the typical 3D tools you can use.
But just before I go back to the A plane, if you want to obtain the view of the nose and lips, what you have to do with 2D ultrasound, it's really important to pay attention to the position of the dot here, because if from here you put here the dot, and if you turn everywhere, it will be really difficult to find the nose. So I go back to the initial position. What you have to do is this dot, you put it on the tip of the nose here. That means when you turn, you will never lose the nose.
I never lose the nose.
And from here, you can rotate and do what you are doing on 2D ultrasounds. That means a view of the nose, nostril, the lips, and the chin. So now we will go and see what we can do with 3D rendering. First, we need amniotic fluid. In this case, it was a nice case because you have lots of amniotic fluid in front of the face. You choose render, and you have different render mode on the system. And this is a routine, and you have to look at this. It's not so nice, but you always have to